The Magic Keyboard is my favorite accessory for the iPad Pro, but there's two big problems. First, it's too expensive, and second, the keyboard layout and feature sets are just not enough for me. So while I can't solve the first problem, today I'm hoping to solve the second. You see, despite its name, the Magic Keyboard isn't all that magic. Like any other keyboard, it's got switches and wires, and a signal is sent from the keystrokes itself to the back of the iPad. And somewhere in there, I'm hoping to break in. By the end of this video, I hope to have the world's first fully customizable Magic Keyboard. Stick around for the ride. Alright, let's start with square one. We're not going to be able to customize this until we figure out what the internals look like, and unfortunately, there's not a lot of precedent for this online. All I could find was an iFixit X-ray and one Chinese video where someone did a complete teardown of the Magic Keyboard. Now, my Chinese is not what it used to be, but with the combined power of Chen Laoshi and Google Translate, I was able to slog through the video and understand most of the steps. Generally, the Magic Keyboard is just as non-repairable as you would ever expect. Everything is completely glued together, and if you think there's much chance of coming out of this with something recognizable, then I have bad news. Now, I didn't want to actually harm the functionality of the Magic Keyboard itself. My goal was to be able to put it back together and have it still work properly, even if it did look a little bit worse for wear. That all started with heating up the bottom of the Magic Keyboard to loosen up the adhesive, and there's a lot of adhesive. Once I heated up the corners, I cut a small seam along the rubber leather frame and to open up and lift off the bottom panel. It was a very, very slow process, and it was very difficult to release all of the adhesive, but slowly but surely I was able to get through it. Now, one thing I noticed while starting to break into it was that there was actually a metal panel underneath all of the rubberized finish, which I was surprised by. I knew that it was heavy, but I had no idea there was actually an aluminum frame underneath it all. That aluminum frame is very thin and probably only serves to protect the electronics underneath it, but it's very interesting to have a truly aluminum build in the Magic Keyboard, and I would love to see an actual aluminum version of this. The iFixit X-ray correctly identified weights at the front of the Magic Keyboard in order to keep it stable and balanced, but unfortunately I couldn't find a way to properly remove these if you hypothetically wanted to just reduce the overall weight of a very, very heavy keyboard accessory. We slowly make our way to the top, towards the hinge, where this is exactly what we are looking for. Underneath all of this, we finally find the little daughter board where everything connects to. This board is tiny. I thought the MacBook Air's motherboard was small, but this logic board in comparison is microscopic. But it doesn't really need to do that much. It just needs to handle the signals from the keyboard itself, the trackpad, and the power, and then distribute those to the iPad itself. Now, while I was trying to remove some of these cables to take out that daughter board, unfortunately I managed to break off one of the capacitors, and I was horrified. I had expected that this whole project would be a disaster and over, and I would have a broken Magic Keyboard to show for it. And thankfully, when I connect to the iPad again, the keyboard still works and the power still works. I don't know exactly what that capacitor was for. It's probably for power delivery, and I might be getting slower speeds than before, but it doesn't seem like there's any sort of problems with the power delivery as far as I can see. The cable we're particularly interested in is this broad ribbon cable going from the keyboard itself to the daughter board, and it is very, very small. I counted 30 pins, which was bad news for me because the more pins that came off of it, the longer it would take for me to solder, which takes us to our next step. If you haven't already watched my building a MacBook video, which most of you probably haven't, you should. But just to summarize the next steps, now I'm going to take this ribbon cable and convert it to USB, and I'm going to use this teensy Arduino in order to do so. All of this comes from a gentleman named Frank Adams, who has a wonderful Instructables guide, which I'll link down in the description. Frank has been a godsend for me because I've asked him many questions during this process, and he helped me along basically fabricating a custom board that would allow me to take this keyboard input, this ribbon input, and convert it into the teensy. This was a long step of the process because it required waiting for these boards to be fabricated, and then it required me to solder them. This was a very difficult soldering project for me, who has only done one soldering project before and has the hands of a football player, not a surgeon. These pins were so small that several times during the process I managed to solder multiple joints together, and I managed to break multiple ribbon cable connectors, but thankfully at no point during the process did I manage to damage the actual ribbon cable on the Magic Keyboard itself. After hours of work, I managed to get all of the solder joints in place, didn't bridge any contacts, and then I checked all my contacts to make sure that they were working properly, and they were. I plugged in a USB to the Teensy itself, and the keyboard didn't work at all. I checked all my connections again to make sure I didn't have a short or anything, but unfortunately, it just didn't make any sense. For whatever reason, the keyboard was sending a constant keystroke over and over and over again, and I couldn't interrupt it with any other keystrokes. This seems to be the way that Apple actually designed their keyboard, and it's the first time I've seen anything like this in the 3 whole times that I've done it. As a last hope, I disconnected those 2 pins that were causing the constant inputs, and now, here we are. Here is the current product as it stands. Did you think it was going to be this one? Obviously, it's not going to be a new one. I'll get some B-roll to get close, but essentially what we have is the Teensy itself sitting inside the custom board that is connected to the ribbon cable from the Magic Keyboard. Technically, the daughter board that sits in the Magic Keyboard is not required, but we'll have to see if it still manages to deliver power despite the keyboard itself being disconnected. We'll see that in a bit. For some quick understanding on the way that a keyboard works, there's essentially a grid of wires underneath your keyboard that each key is connected to 2 of those wires. Each key has its own unique pair that when actually pressed, a signal will be sent among both of those wires, and then your computer actually converts that signal of those 2 wires being sent into an actual key itself. What we have right now are those raw signals coming from those wires, but we don't actually have the conversion methodology to get back to the letters of the alphabet. And so what we need to do is program the Teensy to convert those wires into normal keystrokes. First, let's make sure this thing works. I'm doing this part live just so you guys can join in on the excitement if this all worked out in the end. I've got to be very delicate. Okay. The first step is when I plug this into my laptop, it should be recognized as the Teensy itself. Good sign. So we're programming custom software on the Teensy Duino to be able to just send what wires or what pins are being triggered when we press a key. Now is the moment of truth. The question is, did I manage to solder all of my joints correctly in order to send keystrokes from this to the laptop? Does the laptop recognize these as keystrokes? Let's see. So we're going to start out with control. I'm going to program the globe key as control because I'm used to Windows. Okay, left shift, right shift, left alt. We're going to replace command, right alt. The GUI key is the command key, but I'm going to replace it with option, function. The function key is not working. So the left control key is not working for some reason. That's not good. All right, let's see if all the letters work. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Oh no, the P button doesn't work. Q, R, S, T, U, V, W, X, Y, Z. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, minus, equals, backspace. Okay, here's a good one. I want to replace the tilde key and whatever this other hash is with an escape button. Now the function keys, unfortunately, I'm not going to be able to add on their own, but I might be able to have a keyboard combination in order to get there. We'll have to figure that out later. Obviously, I don't have an insert button, but I'm going to actually program the backslash as the delete key because I think that's very helpful. Now the arrow keys. Right, left, up, and down. I'll do command as function for now. Okay, / period, comma, semicolon, quotes, enter, open bracket. While I want to have an open bracket here, I feel like it's better to just replace my P key since I don't have one right now. And then I will just go no brackets. Caps lock key. In case you were wondering, there isn't a caps lock light. I don't know how I'd be able to customize that, but that's okay. Tab, space, there's no print screen and no number lock. Okay, with that, we can now save. So now we're going to use this custom Python script to actually generate a grid from those results. With this, we should actually be able to create the program that will run on the Teensy that will convert these simple keystrokes into real letters. I'm so nervous. We'll now drop in Frank's code and put our matrix code inside it. Now we can save the sketch and we will compile our code. This isn't right. It's still not right. Still haven't gotten it. Still more to do. Because basically I need to replace these. Okay. There's gonna be a manual mapping here. I am so nervous right now. Okay, now let's check if we can get the media keys or the modifier. We just compiled our sketch. Now we gotta load it onto the Teensy. Very gently. Now we'll disconnect this. Put this back down gently. Now is the moment of truth. We're gonna open up a notepad, plug in the new keyboard. If keys automatically type in, then we've got a problem, but it doesn't look like that's happening. All right, moment of truth. Let's start with an I for InnoIso. Okay, just gotta do it again. So I think I'm just going to go with the current compilation. Press the button again to reprogram it. Force a reboot. Try again. What did I do wrong? I did something wrong. And I don't know what. One last try and then I might have to actually start from the beginning. Wait a second. There's something wrong with this file. All right, let's try this one more time. Okay, I don't know if this will matter, but let's try this. Okay. I was using the wrong GitHub repo for this file, I assume. So what we're going to do is just start again with the keyboard mapping. I know I've done it way too many times at this point. Save. Let's try this one more time, come on. Okay. Oh my gosh, okay, so at least we have something now. Come on, come on. Gentle. Please work. Please work. Yes! Okay, just so y'all can see this live. Okay, ready? Did I get it? Oh, it won't help my spelling, but okay. Now the question is, does it still work on the iPad Pro? Let's unplug this, grab my iPad Pro. Wait, oh my God, I didn't think of this. I totally didn't think of this. The trackpad still works. Okay, I thought the trackpad wouldn't work because I was disconnecting cables from the board on the Magic Keyboard. But the trackpad still sends a signal to the board itself, to the pins in the back of the iPad. So this doesn't disable the trackpad. This is the first ever MacBook Air box. Okay, there we go. First ever Magic Keyboard connected via USB. Oh, gotta get my backspace right. Oh my God, it worked. It worked. It worked. I cannot believe it worked. Oh my gosh. I didn't plan this on working. Okay. Keycode.info is my absolute favorite website in the world because it allows you to actually see the JavaScript key codes that correspond with the keys that you're typing. And it works. It works. Obviously the P key doesn't work, we know that. A backspace key. Have you ever seen a backspace key on a Magic Keyboard? Now there's one. Have you ever seen an escape key on a Magic Keyboard? Wow. Okay, let me just be clear. All of these signals are coming from this USB cable. If I unplug the USB cable, nothing happens. If I plug in the USB cable from the Magic Keyboard, trackpad still works. I can't believe it. Oh, I need to sit down. We did it. 6 months of work, but we did it. The backlight works, so there's still power going to the keys. Now I can't modify the backlight brightness because that's all done in software, but the backlight works. Backlight still works. Let's test one last thing. Does the Magic Keyboard still pass through power? Obviously it should, because we didn't do anything with the power inputs. Turn off the screen so then we'll specifically see it brighten up when we connect power. It's charging. Oh my God. Months, like literally months in the making. Let's do a quick recap. We took apart a Magic Keyboard. We hacked a Magic Keyboard apart and got down to the ribbon cable that connects the keyboard to the board, the motherboard itself. Then we took that ribbon cable and we put it into a separate fabricated separate board that we created ourselves, then connected that board to a Teensy Duino or an Arduino. We programmed that Teensy Duino to take the inputs from the keyboard into regular key inputs, custom to whichever way we like. And then we hooked it up to a USB cable. We can plug that USB cable into a MacBook. We can plug that USB cable into a Windows PC. Here, I'll go get a Samsung tablet. Why not? All right, here is a Samsung Galaxy Tab S8. Now, I don't know why there's dashes, frankly. There's dashes where there should be spaces, but I think that's a OneNote bug right now. Please keep on working. Please still work. Please still work. The result is a USB Magic Keyboard that still works for the trackpad and power, which is amazing to say. Is this a solution for anyone to customize their Magic Keyboard? Obviously not, but it's a proof of concept that this kind of thing could work, and the Magic Keyboard isn't quite as magic as Apple seems to portray. This is an awesome sort of project that I loved doing, and it's actually not the end of the rope for this Magic Keyboard. First of all, I can always connect it back up and it will work properly just as Apple intended. But then also there's other projects that I'm wanting to achieve with this Magic Keyboard. So if you've reached this part of the video and you aren't already subscribed, I highly recommend that you get subscribed to watch more videos just like this. Thank you for watching. I want to hear everything you think about this in the comments, any ideas you might have, any criticisms you have for me tearing apart a Magic Keyboard. I want to hear it all. So thank you for watching, thanks for following the channel, and thank you for all the support that you've given me over the last couple of years. I will catch you in the next one.